Today I would like to show you how to visualize a so-called principal direction, which you can retrieve by calculating principal curvature. At each point on the mesh you can get two values, minimum and maximum, how the surface is bending in each direction, and I am going to use that information to visualize the vector field to create some interesting line flow. So let me show you some example here. Here's some sample geometry that you want to run the vector field, the line field, and once I calculated the principal curvature on it, I'm running the line flow like this. So this is actually the line flow of principal curvature of this geometry, and this is the maximum principal curvature, maximum principal direction. And if I set it to minimum curvature, then the direction of the line will change to 90 degrees, and the flow goes like this. So for this tutorial, just for visualization purpose, I'm going to explain how you can actually visualize those vector field as a line. So it could also be used other than this curvature direction. If you have your own custom vector field on a mesh, you can just visualize it using the same technique. So let's do that. Okay, I'm gonna bring this up and create a new file, and let's start doing this. Okay. First thing, I am going to prepare some base shape. I'm just gonna stick with the pig head for now. Oops, not this. Go inside to the geometry and bring up a pig head, test geometry. And first thing I would like to do, I might need a lot of points in order to create a dense vector field on a mesh. So right now the resolution is kind of fine, but I could make it a bit more dense, meaning having a lot more points on a surface on a mesh. So I am going to use the subdivide node to make more points, including the smoothness. Okay, maybe I would like to control the depths of the subdivision later on, so let's also create a node controller where I gather all the parameters that I want to control later on. Right, and for now I'm going to add an integer value called subd level from 0 to 3, and let's change it to 1 for now and paste it here. Okay, now the base geometry is like this. Now first thing I would like to do is to actually calculate the principal curvature or principal direction. And there is a lot of algorithm to do that, but in this case, since I'm using Houdini, I'm just going to use a measure node, which have an option to just retrieve the principal direction from the input mesh. So that's the easiest way to do it here. And once you connect it, let's change the element type to points so that the direction attribute will be stored on each point, and change the measure to curvature. Then set the curvature type to principal. Now that you have several more options, and for the third option, let's change it to direction. And if I click this show handle button, then you'll see a visualization of a principal direction already made on top of the geometry. And the name of this parameter, name of this direction is called curvature as an attribute. So let's look at it into the geometry spreadsheet. At point you see the vector attribute called curvature, like here. So but if you look at the curvature here, the direction, you don't really know which direction it's facing, either this way or this way for each at each point. So let's try to check that by turning off the handle and make some markers to visualize the actual direction. So let's name this curvature, and I would like to show as a vector. Now the length is a bit too long, so let's make it short like this, something like this. Okay, now that I can see a bit more detailed information, and as you can see, the overall flow for the top of the head seems to go like straight like this, following this line. But if you look carefully, the direction itself, you see that some direction is going upward, some direction is going downward, like this. It's because the principal directions is defined by how much it falls on to the valley. So the direction goes to the valley direction, not the mountain direction, not the climbing up direction, but going down direction. So that's why you have, even though the direction, the absolute direction is the same, but actually the real direction could be flipped 180 degrees. So that will be problematic if you want to visualize the line flow. Like if you want to draw the lines from the nose to the top of the head as a one line, the line will stop eventually at here because you have a horizontal line here. But even though from the nose tip to the middle of the eyes, you have some difficulty connecting all the lines because the vector field itself is not consistent. Sometimes it flips 180 degrees, sometimes it's not. So knowing that information, I have to modify some of the vector field that I have here when you want to create a line flow using this kind of vector field, the principal direction. So keep that in mind, and let's try to do that. And before get it into that, I also would like to show. So I would like to show another principal direction. So currently this is the minimum principal directions, but if I change to the larger option here, then you have a 90 degree rotated vectors, which is going horizontal directions, which means is that the steepness is the maximum. Steepness of that direction is the maximum, like here. Like if you see it as tube shape, you might understand. So in this horizontal direction, the steepness is really high, and if I change it to the smaller, and then this direction is a bit more straighter, so the steepness is minimum. So that's the meaning of the principal direction. And I would like to be able to switch between the minimum principal direction or the maximum principal direction. So in order to visualize it, which one you want to visualize it. So let's create some other parameters to switch between the minimum and maximum. And for that, I am going to create a toggle. And let's name this min curvature. So if the toggle is on, then let's use the minimum principal curvature. If the toggle is off, then use the maximum toggle, maximum principal curvature direction. Right, so for that, I'm going to create two measures by copying one of it, and then I am going to set the first measure to be a larger principal direction and the second one to be the smaller principal direction. And I am going to create a switch. And for the parameter here, switch input, I'm going to link the value from this minimum curvature. So I'm going to copy this parameter and paste it here, like this. Okay. Alright. Now let's hide out the vector field for now. Now I'm going to create some points on top of this mesh in order to use it as a starting point of a line flow. So I'm going to just use a scatter. And I might also be wanting to change the number of points on the mesh. So let's create another parameters. Let's name this pt num or numpt, saying number of points. Let's make 10,000 as a maximum value, could be any value though. And then let's set it to something like 3,000 and let's copy this parameter to here. Right. Okay, now that I'm be able to control the number of points on a mesh, let's also see the generated point attribute if I use the scatter. So the curvature has been sampled from the mesh when I used the scatter on top of the mesh, so that's good. We will going to use this parameter later on, attribute later on. Now after this, I'm going to create a ID for each point on the surface on the mesh in order to create a actual line flow later on. So I'm going to create a point wrangle, create a simple code, create an ID attribute, and then just pass the point number to that ID, so that currently the ID here, the point number here, and the ID is identical, like this one. Right. Looks good. Now let's name this ID. Now then the preparation is done. Let's try to create a line flow animation from each point using the vector field that we have right now. And keep in mind that the direction, even though you have the minimum direction or maximum direction, like this, it's a bit hard to see. The direction doesn't always go from here to here, because if you really look at the actual direction, as I said before, for example, this direction, this principal curvature, the principal curvature at this point goes left side, but on this point it goes right side, sometimes left side and right side, and so on. So even though the direction seems one continuous vector, the direction itself is 100, sometimes 180 degree flipped. So keep that in mind, and let's consider how to make a line flow out of these information, which is not that hard to do. So to make an animation, I'm going to use a subsolver. So let's connect the points, list of points with an ID into the first input of solver, and for the second input, I'm going to just input this mesh with the curvature to the second input in order to sample a curvature. Right, now let's get inside the subsolver and let's write some code here, which is the most important part of this tutorial. Right, now connect the prep frame output to the first input of the point wrangle, and I'm going to name this sampling curvature. And let's also connect the second input geometry, which is this mesh, to the second input of this point wrangle. Right. Now let's bring up the code editor and write some code in order to create a line flow. Now, before getting into the actual coding, let me explain what I would like to do here. So let's say we have a geometry like this, and we also have a vector field, which is derived from the principal directions, like this. And as you can see, what I would like to do is to have a point somewhere, anywhere on the surface, and from that point create a continuous line flow following that principal direction. And even if the curvature, the principal direction is facing in 180 degrees flipped directions, like here, you still want to continuously create a line flow in this direction. So to do that, you need some trick to calculate the actual directions. The way I thought of, I'm not sure if that's the efficient way to do that, but what I'm going to do here is to first pick any point on a mesh like this, and then from the initial point sample a vector field, the principal directions from the mesh. So the mesh have a vertices, which at each vertices you have the principal directions like this. And what I want to do is to pick the closest point from this point on a vertices, on a mesh vertex. So which is, find the closest mesh vertex from this point, which in this case this could be this point. So this will be the closest point, right? So at this closest point, sample a principal direction, which is this direction. So bring that direction onto this point, the initial point, right? Now, what I want to do next is to move this point to that direction with some amount of distance, maybe using some parameters with your own needs. Now, after moving it, what you want to do next is to resample again using the closest vertex on the mesh, this point. So you have another direction moving like this, and do the same in next frame. Maybe next frame you want to sample this one, so maybe going this way. And at next frame you might find this point to be the next point. Now this is the case where the vector field, the principal direction is facing a negative direction, the inverted direction from the previous directions. So this is where you want to calculate, this is where you want to make a condition. If the direction is going the inverted way, then you want to flip this direction 180 degrees and use the flip direction of that vector. So in this case, if it's going inverted direction like this, then just flip it, and meaning just multiply by negative value and then -1, then just go to the inverted direction of this principal direction, so that you can keep this line smoothly going to a specific direction. Now it's easy to check if the direction and the next direction is in inverted direction. You can just use a dot product of two vectors, vector 1 and vector 2. So if the dot product is positive, then the angle between two vectors is more than 90 degrees, meaning it could the range of the vector 2 could be, if the vector 1 is like this, then the range of the vector 2 could be somewhere around here. Because if it's perpendicular to vector 1, then the value will be 0. And if it's going the inverted direction like here, then that means the dot product is negative. If it's positive, then the dot product should be more than 0. So this is the condition where you want to find out where you want to go. If the dot product is negative, then just multiply this vector with -1, then the vector will be flipped 180 degrees, and you can continue with a clean line, continuous line. So that's the trick. Right, so keep that in mind. Let's actually code that. Okay, now for each point, I want to find out the nearest point on the mesh, the nearest vertex on the mesh. So use near point, second input at P, and get the curvature information at that near point. So I'm gonna name this n curve, point, second input, curvature attribute, curvature attribute at npt. Okay, and let's calculate the dot value, dot product of two vectors, one on the point, the actual point, and one which you find out on this near point. So the current curvature is V curvature, and let's use the dot product, and the one that you find on the nearest point is n curve. Okay, so and also let's calculate whether the dot product is negative or or a positive. So to do that, the easiest way I could think of is to divide the dot product with the absolute value of dot value. So as a result, if the dot product is negative, you'll get -1. If the dot product is positive, you get +1 with this calculation. And use that information, you just want to multiply you want to create a new directional curve vector by multiplying the curvature on the near point. Multiply this by this variable. So if the dot product is negative, the multiplier will be -1. if the dot product is positive, it's +1. To keep the direction constantly going on the same direction. Right. If you want to keep the line really straight, then you also might want to give another conditions, like if the absolute dot value is like more than 0.5 or something like that, so that you can restrict the range of this arc to more like this direction. If it's 0, you accept this kind of arc. If it's 0.5, you'll have something like this. If it's more than 0.7 or 0.9, you have a really steep range. But in some case, if you have too steep range, the line flow will just stops if you couldn't find any continuous line within that range. So I'll just go with this range, the broad range, more than 0, so that the line will not stop eventually. Right, so I'm not going to add any condition here. It's really up to you. Right, and using that direction, I'm going to update the position of the point. And let's multiply this by some value of the moving distance. I'm gonna name this move here. And then finally update the current curvature with the curvature that you have created here. This direction. Okay, apply, accept. And let's actually see the animation if the points is moving from each initial position. So let's get out of this subsolver, but before doing that, let's promote the parameter that we have just made here, this move parameter. I also want to link this parameter with the one it's inside the null controller, so let's go to the null controller and give additional parameters here. Let's name this move. Oops. And name this, let's set the range from 0 to 0.1. And I'll just set it to 0.02 as an initial value. And let's copy this value, copy this parameter, going back to the solver and paste it here. Right. Okay, now let's go outside the solver and let's check the movement of the point. If I play it, yeah, it seems to go well. The point is moving along the curvature without going inverted direction. But the problem here that I can see is that some of the point is going outside the geometry like this. So to keep the point moving on top of the surface, on top of the mesh, I'm going to add another function, another component here, ray node, so that if the points go outside the surface, just project the point on top of the mesh. And I'm going to change this to minimum distance, and that's all I want to do to keep the points on top of the mesh. Right, let's try it again. Now this time seems to work well. Alright. Now the flow seems to go well. I just want to visualize it as a line. To do that, there is a really good node, which is called trail. So let's just use this. Connect with the solver. And if I play it, now I see some problem here. This is just creating a bunch of points from each points to create a trail, and I also have to set up the lengths of the trail. So I'm going to change this trail length, the maximum trail length, to be the maximum, same as the maximum number of this frame. So let's keep this frame a little smaller, and then let's set the trail length to fn, like this. Okay, so that I'll have a bunch of points creating a trail as a list of points. Okay, now this is just a point right now. What I want to do next is to create a curve from those points. And if I look at the attribute of each point, I can see that there are ID attached to each point, and each point meaning this is belongs to one continuous trail. So what I want to do is to create a trail curve based on this ID value, ID attribute. So let's create an add attribute, and then go to the polygon, go to group, and for the add parameters, set it to by attribute, and for attribute name, I'm going to set it as ID, and voila, you have a line flow, or visualizing the principal curvature, principal direction of that mesh, specific mesh. Okay, and this is kind of it in order to how to visualize the curvature as a line flow. Now to make it a bit more prettier, I'm going to blur this. I'm going to smooth this a little bit using attribute blur, just a little bit. Set it at, check off this pen border points and make a little bit of smooth. Right, that looks good. And also let's color this line using any constant color like red. And I also would like to show this on top of the mesh. So let's merge this with the mesh, which is, the original mesh could be this one. So let's visualize on top of this mesh. Okay, so to do that, I'm going to merge it. It's this one. Now the texture is unnecessary here, and the curves is going inside. Some of the curves is going inside the surface, so let's also offset each curves a little bit outside the surface. To do that, first of all, I'm going to delete the attribute of this base geometry, maybe deleting some texture information for which is inside the UV, and maybe this material attribute as well. Okay, right now it became gray. Now let's also lighten the material up by turning this diffuse to lighter value. Okay, that looks good. Now next thing, I would like to offset the curve out just a little bit outside the surface. So to do that, I need to have the direction where the curve should go, and that information could be calculated by, let's go back inside the solver, and if you look at this ray node, you have an option saying point intersection normal. So by checking check this on, check this on, I can have the normal information on each point based on the input geometry, the intersected geometry, which is this one. So if you look at the normal, you have this information, and this direction could be used for the offset, the curve offset. Right, let's go back, and maybe after the curve I can have a point wrangle and do some simple offset calculations. So point P, move the point with the normal direction, multiply by some moving value. So let's name this distance, and if I change the value, okay, I have to reset this simulations first. Okay, let's play this again. Now let's try again. Yeah, and the offset seems to work well. Right now, when I merge this, I have another problem. The mesh became black because it's missing the normal information, so I'm going to attach the normal node to the base mesh, and that's it. That's pretty much it. Let's connect with the final null node, and let's also give a bit of offset value so that the line will be shown just outside the surface, something like 0.03 or 0.25. If you want to use more lower value, like if you want to prevent having those kind of situations, you can, instead of using the original one, you can use the subdivided mesh, which will be more easier to use lower value for the offset. Yeah, that looks good. Let's just set it to 0.01, and that's it. Now let's try this out by changing some parameters. Let's reset the value here and play again. So this is the maximum principal direction visualization. Let's set it to play once, and let's change this to minimum principal direction. Reset the solver and then play again. And now it's going to the different direction, and the curve flow, the line flow looks really smooth as I expected. Looks good. Now if I change this to some different geometry like rubber toy, it still works the same way. First let's reset, and then do the calculation. Still works pretty good. So this is the minimum direction. And if you change to the maximum, control click the brain and play again, and you see another type of direction visualized as a line flow. So this is just visualizing the vector field on top of the mesh, so it doesn't even have to be principal direction. If you have your own custom vector field on top of the mesh, you can just visualize it in the same manner. But in that case, you might not need to have a condition like I did in the solver in order to flip the direction based on the nearest point vectors, but it depends on what kind of vector field that you have. But for principal direction, the best way to visualize is like this, I thought. So this is how I did it. And I found, now I hope you find it interesting. I guess you could use this flow to create some gorgeous visualization, probably. I just wanted to share how to actually simulate this kind of curve flow. Okay, and this works on any kind of mesh. Right, that's it. Thank you for watching, and see you next time.